In this video, we will review Chapter 10 of your Wintec 1010 library book, Symbols on Schematics. Okay, Chapter 10, Symbols on Schematics. So 10.01, schematics represent systems, symbols stand for each part, and lines show how they are connected. 10.02, a well-drawn schematic is drawn with lines connecting the components in a logical sequence. For instance, you'd have your power source, your operating devices, back to your power source. 10.05 talks about how all systems work alike, even if it's electrical versus fluid power. One uses wires and one uses pipes. One conducts electricity, one conducts fluid. In both cases, a breakdown interrupts the flow. 10.06, we talk about the differences in the types of schematics. So 10.06, piping drawings use arrows to show flow. Electrical diagrams use voltage or color codes. 10.07 to 10.11, another difference are lines. Lines have different meanings in different types of schematics. So if you look at figure 10-1 at the dashed line, in the electrical diagram it would mean an exposed wire. If we were looking at a fluid power like a hydraulic system, the dashed line would mean a drain line. In any case, when you're working with schematics, always check your drawing for a legend, so something that'll tell you what some of your lines or symbols are. 10.14 and 10.16. Symbols. The meaning of certain symbols also depends on the kind of system the schematic shows. Most piping symbols differ from fluid power symbols, and electrical symbols differ from both. So figure 10-3 shows you three symbols. They're all drawn differently, but they all mean the same type of thing. So figure 1 up above is a check valve in piping. Figure 2 to the left is a check valve in a fluid system. And figure 3 to the right is a diode in an electric circuit. In any case, they all prevent flow in one direction. In this particular case, flow can only happen from left to right. 10.17 and 10.19 talks about drawing titles. So we have two drawings, 10-4 and 10-5. If we look at the title of them, it says chilling chamber refrigeration system, and it's the same one, same drawing title for both diagrams. However, we don't know if it's electrical, we don't know if they're hydraulic, we don't know what they are because it doesn't tell us in the title block. But if we look at our symbols, you can use your symbols to figure out that 10-4 is electrical and 10-5 is piping. 10.20, interpreting a combined symbol is often a matter of common sense based on your knowledge of what other symbols mean. Figure 10-6 shows three piping symbols. So the first one is a flanged reducing T that cuts down the size of a branching pipe. The numbers indicate that the main line is 4 inches in diameter and the branch is reduced to a 2-inch diameter. The second symbol is a screwed elbow, also called a threaded elbow, that turns the pipe 90 degrees. Elements of the first two symbols are then combined to produce the third symbol, a 90-degree flange reducing elbow. So 10.21 talks about some other clues. It's not usually hard to discover what kind of a system is portrayed in a schematic. There's all kinds of clues on your drawing. So you have your title, you have a legend, you might have a parts list, there might be labels on your drawing, there might be numbers for volts or sizes, and notes by the engineer or technician who prepared the drawing may make it clearer. So 10.22 to 10.26 talks about creating a schematic and the process that's followed. So step 1, the engineer considers size, efficiency, cost, and codes for a circuit. Step number 2, they'd create a sketch to find the best layout of the chosen components. And then finally, step 3, the actual schematic diagram would be created. (10.27) Using a schematic. The most important function of a schematic to you as a maintenance tech is to help you maintain the system and to fix it when it breaks down. In order to use a schematically effectively, you must thoroughly understand how it works. (10.31 to 10.33) Understanding symbols. So different ways of representing a part. So figure 10-10 shows a 45-degree Y fitting, but represented 3 different ways. We have a picture of it, a pictorial picture of it on the left. We have a double line drawing in the middle, and we have a schematic symbol on the right. So schematics save time and are universally recognized. They can show a complex system on a small drawing. 10.34 to 10.38. They're talking about schematics showing details. So figure 10-11 shows schematic symbols for 3 different 45-degree Y fittings. They all resemble the schematic symbol in figure 10-10. Anyone who knows how to read piping symbols does not need the written descriptions below these symbols. The schematic symbols alone provide all the information shown. (10.38) talks about piping lines. So figure 10-12 shows piping intersections and crossovers. So the ones that connect have a dot on them, and the ones that just cross over each other, they don't have any dot on them. They're not connections, they're not intersections. 10.39 through to 10.42 talks about identifying your symbols. Tables of symbols that are standard in most industries appear in this chapter and the upcoming ones. You're always going to try to look for a legend on your drawing, so you can identify components using a legend. That's what figure 10-3 is showing us. 10.43 to 10.46 talks about identifying connections. Once you've identified the individual symbols, you must analyze the schematic to see how the parts go together. Figure 10-4 shows the kinds of lines used in fluid power schematics. And figure 10-15 shows a fluid power schematic with a list of parts and their symbols shown in a legend. 10.47 to 10.51, reading diagrams. So reading a schematic for troubleshooting. So the steps you would follow. It says step number 1, identify your system. Step 2, grasp the nature of the system. Step 3, figure out how the system should work. Step 4, state the problem. And step 5, think why the engine might be misfiring. Step number 6, study each area of your schematic. And step 7, examine the actual circuit. This method of reading the drawing and relating it to the actual system is an effective way to use a schematic. It takes a little bit of time and patience plus some thinking, but it'll help you figure out what trouble you are looking for and what to do when you find it. In the upcoming chapters, we'll learn more about electrical symbols and diagrams, how to read them, and how to use them in your work. That concludes our review of Chapter 10, Symbols on Schematics.